All right, guys, so today we're working on section 1.2. Your learning goal is that you should be able to write functions representing translations and reflections. You also want to be able to write functions representing stretches and shrinks. So these are the four concepts: translations, reflections, stretches, shrinks. Horizontal translation. If you have a function and you replace the x with either x plus h or x minus h, that's going to be a horizontal translation of the graph. If we replace x with x minus h before evaluating the function, that's going to shift the graph to the right. So replacing x with x minus h moves it to the right. Let's check that out. Let's do it. Let's use our absolute value function. So we're under math, num, absolute value. Let's just do the absolute value of x. Now let's replace that x with x minus 2. X minus 2. So now we're going to have math, num, absolute value, x minus 2. Now, based on this rule, it should move the graph right 2 units. Let's see if it does. So the red is our new one. So here's our original one, and here is our new one. And it did shift it to the right one. Okay, so what do you think happens then if we replace x with x plus h? Well, that's going to move the graph to the left h units. Okay, up and down. The graph of y equals f of x plus or minus k is a vertical translation of the graph of the function where k is greater than 0. Adding k to the outputs shifts the graph up. Subtracting k from the outputs shifts the graph down. Okay, lots of words there. Here's all it's saying. If I have this function, absolute value of x, and I want to compare that to math, num, absolute value of x, and let's say plus 3. Now that's on the outside, so that's like going to be adding it to the output. So when we have it on the outside like that, rather than the inside, that should do what? Well, let's read it. Adding k to the output, shift the graph up. Let's see if it does. Here's the original, and here's the new one, up 3. Okay? So our whole goal with this is to be able to do all of this without having to use a graphing calculator. It really helps us in later math if we can just visualize that. If we subtract k from those outputs, in other words, outside of the parentheses, we subtract k, that's going to shift us down. All right, so let's talk about a couple ones here. So what about this function? We have 2 absolute value of x plus 3. What do you think is going to happen from the original function? It's going to take it up 3, and then it was going to be a vertical stretch by 2 as well. We haven't gotten into that, but that's what would happen. Now, it says to write the function g whose graph is a translation 2 units to the left of this function. If I want to go 2 units to the left, to do that, I have to replace x with x plus 2. So I'm going to take this function that I've got, I'm going to now call it g. 2 stays the same. Here's the x. Absolute value stays the same, but that x has to get replaced with x plus 2. Everything else stays the same. So that should be the exact same graph, but just shifted to the left 2. I'm just going to put it in quickly so you can see. Now the other thing you can use, if you don't like using the graphing calculator, you can use Desmos. I know some of you used that when you were in junior high. But you got to remember that when you take the ACTs, that you can't use Desmos on that. So it's really good to learn how to use your calculator now. Hopefully you learned it a little bit last year in Algebra 1. Okay, so there's the new function that we think should take that function to the left 2. Let's see if it does. Here's our original, and our new one should just be a shift to the left 2. Yep, that did it, didn't it? Okay? All right, so now using this same function, write the function g whose graph is a translation 3 units down. Well, now I'm going to have to take this same function, keep it exactly the same, and I'm going to have to subtract 3 from it. So I'm going to have to go down 3. And so now simplifying that, that's going to become g equals 2 absolute value of x. That's because these two just cancel out. So here's my original, and then I want to see, does 2 absolute value of x, that should be down 3 from the previous one. So here's our original, and then here's our one shifted down 3. Okay, makes sense? All right, so that had to do with left and right. So again, that is going to take us to the right h. This is going to take us to the left. Okay? If it's on the outside and it's plus k, adding it's going to take us up. Subtracting is going to take us down. So, reflections. If I have this graph y equals f of x and I'm going to reflect it, all I want to do is a reflection in the x-axis. We're going to multiply the whole thing by a negative. If we're doing a reflection in the y-axis, we have to replace the x with a negative x. So in the x-axis, we multiply the whole thing by a negative. In the y-axis, we're going to have to replace the x with a negative x. So this is when we're multiplying outputs. That means the entire function gets multiplied by -1. This one, if we want to go over the y-axis, just the x gets replaced with a negative x. The inputs are the x's. All right, so write a function g whose graph represents a reflection over the y-axis for f of x equals x squared plus 5. So I'm going to take my original function, and if I want to reflect it over the y-axis, that means that I'm going to have to do f of negative x. What that means is wherever I have an x, I want that x to get replaced with a negative x. So here's an x, here's an x. So to find my new function, f of negative x, here's this x, put negative x, then it's going to have to get cubed, and then we have to add 5. So this new function g then, see at first I called it f of negative x just to explain what I was doing. This new function g is going to be negative x cubed plus 5. If you want to check it, I'm going to stop checking everything because I know it slows down the notes a lot, but I think it's cool to see. To do x cubed, I push this caret key, x cubed plus 5. That's my original, and now I want to do negative x, negative x cubed plus 5. Zoom 6. Here's the original function, and here comes the new one, and we wanted it to be a reflection over the y-axis. See how this point goes here? It's a reflection. Perfect. Okay, example 2. Write a function g whose graph represents a reflection over the x-axis for this function now. Well, to get that reflection in the x-axis, we have to multiply the entire function, the outputs, the entire thing by -1. So that means I'm going to be doing negative f of x. That means this entire function has to get multiplied by a negative. Okay? So if I'm doing negative f of x, my new g function is going to be negative x cubed, multiply the whole thing by -1. That's going to be my g function. One more check on this one. You don't have to put it in. Just watch me. So I'm going to just change this. Now I'm not using a negative sign here. I'm using subtraction. This one was the negative key. Graphing it. Here's my original. I wanted to have a reflection of the x-axis. So see how it flipped it? Right over that x-axis. Okay. Lots to learn today, as you can tell. Okay. Horizontal stretches and shrinks. This works when a is greater than 1. So to apply a horizontal stretch by a factor of a, this is horizontal, we replace the x with a 1 over ax. That's weird, isn't it? Let that sink in. To do a horizontal stretch, meaning getting wider by a factor of a. replace x with 1 over ax. So if I want to do a horizontal stretch by a factor of 2, I have to replace x with 1/2 x. This will stretch all x's away from the y-axis by a factor of a. Note, this may change the vertex. Okay. To apply a horizontal shrink by a factor of 1 over a, replace x with ax. So let's say we want a horizontal shrink by a factor of 1/3. We would replace x with 3x. This will shrink all x's towards the y-axis by a factor of 1 over a. Again, note this may change the vertex. All right, let's try it. Here's our function. Okay, so this function would have a vertex at 2, because it's a shift to the right 2 and up 1. So that's the way it's starting. Write the function g whose graph is a horizontal stretch by a factor of 3 of the graph of f. Okay, so I'm going to write my function f of, I want to do a horizontal stretch by a factor of 3. Horizontal stretch, replace x with 1 over 3x. So I'm going to have to do f of 1 over 3x. So that means in my function, wherever I see this x, just that x has to get replaced with 1/3 x. Everything else stays exactly the same. That's the way it would look. I'm supposed to name it g, so I'm just going to name it g now. This is just showing what I did, and now I'm giving it its proper name. Okay? All right, let's try the next one. So on the next one, we have got this problem. Write the function g whose graph is a horizontal shrink by a factor of 1/2. Horizontal again. Horizontal shrink by a factor of 1/2. Okay, so what do? Do I replace x with 1/2 x? Nope. We do the opposite of what we would think. Just like when we were doing these shifts left and right, remember how x minus h took us to the right? It's subtraction, but it did the opposite. It took us right. This is the same way. We want to do a shrink, but we replace x with the reciprocal of 1/2. So kind of let that sink in. It's always the opposite when we're doing x's. So to do this then, I'm going to have to do f of 2x. So that means back here in this function, x is getting replaced with 2x. So this is going to get replaced with 2x. Everything else stays the same. And now I need to call it by the name they want me to call it, g. That would be it right there. Okay? These are the most difficult things in my opinion. The horizontal stretches and shrinks are the hardest ones to grasp. The verticals aren't as bad. For a vertical stretch and shrink, if a is greater than 0, to apply a vertical stretch by a factor of a, multiply the outputs, meaning the entire equation, by a. This will stretch all y's away from the x-axis by a factor of a. Note again, this may change the vertex. All right, so if I wanted to do a vertical stretch by a factor of 2, I just multiply the whole thing by 2. But I never go inside the parentheses or inside the absolute value. Okay? If I want to do a vertical shrink by a factor of 1 over a, multiply the outputs, meaning the entire equation, by 1 over a. This will shrink all y's towards the x-axis by a factor of 1 over a. Okay, so here's our function again that we're starting with. Write a function g whose graph is a vertical stretch by a factor of 3. Well, this is easy. For the vertical ones, we just have to do 3 times the entire function. So 3 times the entire function. See what I did? 3 times this entire function is what I have to do. I'm going to call it by its proper name. I do not distribute inside of here. This is all together, okay? I can't go inside of there. So when I multiply this and this, I multiply this part of it is going to be 3 absolute value of x minus 2 plus, and then I have to multiply that by 3. So see what I did? I multiplied this by 3, and I multiplied that by 3. Okay, and then I want to just leave it like that. That's it. Write the function g whose graph is a vertical shrink by a factor of 1/2 of the graph of f. Okay, well now I'm just going to have to multiply the whole function by 1/2. So that is going to become my g function. I have to do half of this, which is just half of that, plus half of 1, which is that. Okay? So this can be some difficult stuff. The thing I want you to remember is that x's kind of work the opposite of the way you would think. You know, so when you want to do that horizontal stretch by a factor of 5, you replace x with 1/5 x. But if I wanted to do a vertical stretch by a factor of 5, I would just multiply the whole thing by 5. Okay? If I want to take a function to the left 2, you would think I would put x minus 2 in there, but it's the opposite. It's x plus 2 to go to the left. So with the x's, it's always the opposite of what you would think. With the y's, it's just the same as you would think. All right? So I was just kind of think of this as, I don't know, somewhere. Whenever we're dealing with x's, it's going to be the opposite of what's intuitive. Y's, it's going to be the same as what you would think. All right? So there is something else called this extra practice, but I want to wait on that. I want you guys to stop the video right now, and I want you to go in and do the Big Ideas Assignment 1.2 before you try to do these problems. And then you're going to, so stop the video, do the big ideas, and then come back, and I want you to try doing these. Okay? All right, welcome back. So I'm going to go through these kind of quickly because you were supposed to work these ahead of time. So in exercises 1 through 9, write a function that represents the indicated transformation. I want to go to the left 2 units. That means that I'm going to find this function g, and it's going to stay the same, except for wherever I have an x, I'm going to have to replace that x with the parentheses, x plus 2. It's the opposite of what we would think. So for this one, you should have had the absolute value. You can either have this answer, or you could have this answer. Either one of those two. You would have to have the parentheses in this case. Here's what people think they can do. That is wrong. Okay? That is wrong. There, all you're doing is you're just adding 2 to the whole thing. That's not right. Is that the x has to get replaced with x plus 2. So then this whole thing is being multiplied by the 1/3. Okay, on this one, I want to go 6 units down. That just means I'm going to subtract 6 from the whole thing. So this function, the first part would stay the same. -1 minus 6 is minus 7. To go 7 units right, that means that wherever I have an x, the -2 stays the same. There's an x. I have to use parentheses. To go 7 units right, I'm going to have to do x minus 7 and then plus 2. Now, because this isn't inside absolute values or anything, I can simplify it. So you can either leave it like this, but a better answer would be g equals -2x plus 16. That would be an even better answer. So I want to show you that, because that does not seem intuitive at all, does it? But watch. My original function, -2x, whoops, wrong button, -2x plus 2, and then I wanted to see -2x plus 16. And that's going to supposedly take it to the right 2 units. And let's see if it does. Do our zoom 6. So here's our 2x plus 2, negative 2x plus 2, and here's our negative 2x plus 16. So it was supposed to go to the right 7. 1, 2, 3, 4, 5, 6, 7. Yep, it did it. Okay? You can check your own. If you thought you did it correctly, but you didn't go to this right 7 units, then you messed up. Wherever we have an x, replace that x with x minus 7. All right, reflection in the x-axis. That's where we have to do negative f of x. So I have to multiply the whole thing by a negative. So for that answer, you should have had negative 1/2 x minus 8. A reflection in the y-axis. That means we just replace the x. Everything stays the same, but the x gets replaced with a negative x. And even though it's an absolute value, I can't take the absolute value of it because there's another number with it. You have to leave it like this. You can check all these if you want to on your calculator. A vertical shrink by a factor of 1/5. So to do a vertical shrink, we multiply this whole thing by 1/5. So you should have had g equals negative x. A vertical stretch by a factor of 4 means this entire thing is going to get multiplied by 4. We don't go inside of this bracket though, so it's going to be g equals 4, absolute value of x plus 3 plus 8. On this one, a horizontal stretch by a factor of 6. Horizontal means we're replacing x with the opposite of what we would think. So it's going to be g, let me start with, it's going to be f of 1/6 x. Here's another x, replace it with the 1/6 x. So my function is going to be 3 times 1/6. This is an absolute value, it's not getting squared, I'm allowed to multiply it out. So that's going to be 1/2 x minus 9. For this one, I want to do a horizontal shrink by a factor of 1/4. So that means I'm going to have to do f of 4x. It's horizontal. So everything stays the same except my x is going to get replaced with a 4x. So that's going to become, my g function is negative the absolute value of 8x plus 1 minus 4. Consider the function f of x equals the absolute value of x. Write a function g whose graph represents a reflection in the x-axis first. So I'm going to do that first. To do a reflection in the x-axis, I have to do the negative of the function. There's my first step. Followed by a horizontal stretch by a factor of 3. Okay, so now I'm going to have to multiply this by a factor of 3. I'm just going to call this my second f function. So I have to multiply it. Oh, hold on. Followed by a horizontal stretch by a factor. Horizontal, not vertical, horizontal. So x is going to have to get replaced with 1/3 x. Let's mess that up. Horizontal stretch by a factor of 3, I did that part. And then a translation 5 units down, so I can just subtract 5. So my g function then is negative 1/3 x minus 5. Which of the transformations in section 1.2 will not change the y-intercept? Okay, well I know what this looks like to start with. It's a shift up 3 and it's this V shape. So right here is its y-intercept. So if I don't want that to change, I can't move it up or down or left or right. If I reflected it over the x-axis, it would go down like that. I don't want to do that. But if I reflected it over the y-axis, it wouldn't change it. So the only thing I could do would be to reflect over the y-axis. To do that, I have to replace x with negative x. Watch what that becomes. What is the absolute value of negative x? I'm allowed to do that because it's just by itself. Well, the absolute value of negative x is just, see how I get right back to where I was before. because I'm allowed to do this. The absolute value of the negative is a positive, so that's why this works, that reflection. Okay, so you would just answer it like this, a reflection of the y-axis. All right, guys, I hope you did okay on that. This is some challenging material. This is one of our harder chapters, this chapter 1, which is weird. It's where we start. But this kind of material will get easier as we go on, so don't lose your confidence, okay? Even if you didn't do so well on this, go back and rework through it. See if you can make it better, okay? Just try your best and keep working at it, and it'll come, okay? Get on any Zoom calls if you need help. All right.